preparations workshops. We would have started last week, Tuesday, which was the 21st of April. And we went through circle theorem, trigonometry last weekend. And today and Thursday, we will be looking at algebra, relations, functions, and graphs. Today we're doing part 1. And on Thursday, we will be doing part 2. Now, I will be giving some shout outs to school students who would have been a part of the session on Thursday. So, type the name of your school, your name in the chat so that on Thursday, I can also big you up. All right. So Taki High School, Edwin Allen, the Queen School, Manchester Institute of Learning, Kingston Technical High School, Eltham High, Vauxhall High, Waterford High, Happy Grove High, Norman Manley High, Alphonsus Davis High, Cambridge High, Happy Grove, Glenmuir High, Kempsale. I'm looking at Denby High. Let me go down a little bit quicker. Garvey Massey High, Kingston High, Port Fort, East Secondary School, Fogo Road, St. Catherine High, El Shaddai Home Schools, Green Pond High. We also had students from Clarendon College, Morant Bay High, and I'm going down as quickly as possible. We saw students coming from Meadowbrook High School, as well as York Castle, St. Catherine High, Titchfield High, Iona High, Guysville High. Let me see if there's anybody else who I have missed. Yes, and we had from William Knibb Memorial. Oh, and I'm seeing one person here from Mayday High School located in Mandeville. We had someone from Portmore Community College. So we had students from right across the country, Mavis Bank High, as well as Uartan High. And today we have for our presenter, Dr. Kirk Morgan. He is one of the lecturers at the University of the West Indies in the Faculty of Science and Technology, specifically the Department of Mathematics. So just in case you are planning to attend UWI and you're thinking of maybe, just maybe, you want to find yourself in the Department of Math, you will see Dr. Kirk Morgan as one of your lecturers. So welcome to everybody who is here this evening. Sir will be just showing you his face, but due to internet connectivity, he's going to be closing his camera as soon as he says hello to you all. So just bear with us. We know how the internet goes. Remember, type the name of your school in the chat and your name so I can give you a shout out on Thursday. Over to you, Dr. Morgan. We're not hearing you, Dr. Morgan. Your mic is closed. I know you're talking.
Okay, thank you. Thank you, Mrs. Johnson Burrell. Okay, welcome again, students, to this workshop. And like I said, we'll be doing now. Well, the topics will be functions, graphs, algebra, and so on. So, because of the feedback, I'm going to eventually come out of I'm two different devices one time. So I'll just log out of this one. So welcome to this workshop. And I look forward to having a great evening with you today. All right. Thanks again, Mrs. Johnson.
You're welcome, sir. And in the meantime, while sir is logging out of one machine to come back to us, students, remember, the session is streamed straight to YouTube. So at the end of the session, just in case you missed anything, you're able to view it on YouTube. Plus, the sessions that were held last Tuesday and last Thursday are also available on YouTube to you. Just type in Region 7 Math Team. As a matter of fact, just subscribe to our channel so that whenever we have these sessions, you're able to see them firsthand. You know, you get the notifications. So just head over Region 7 Mathematics Team on YouTube. Over back to you, Dr. Morgan.
Okay, thank you, Mrs. Johnson Burrell. Well, I think I like what I'm hearing. I'm not hearing the feedback anymore. That was very distracting. It was kind of distracting me. All right, so again, like I said, I'll be talking about algebra, relations, functions, and graphs. Are you all hearing me?
Yes, sir.
All right.
Yes.
Okay. All right, so let's start now. So we're going to look at some questions that we actually have, which I'm supposed to be doing for you this afternoon. So the first one, okay, so it says that this, well, you need to know each time you say a question, you need to know exactly which topic you're actually under. If you're under, like, if you're under relations, if you're under functions or algebra, or, you know, we have something called linear programming. So this comes as what we call linear programming. So this is really a linear programming question. All right, so it says that a rental company has X cars and Y minivans. All right, so first, so there are two types of what? Of rental, of cars, okay? Or vehicles then, I should say. So it has cars and it has minivans. So it said the company has at least 8 vehicles altogether. So what you need to understand, ladies and gentlemen, is that to form the inequalities that they're asking to form, you have to understand now that you have to have quantity. They're talking about quantity. All right? And they are talking about maybe, say, number of, say, persons or so. So you have to look at what they are saying. So if they are talking about quantities, then think about what was the quantities. They're talking about costs, because these are all basic principles to form your inequalities. So look at quantities with quantities, cost with costs. If you're talking about number of people, it has to go in the same order. So first thing first, it has X cars, where X can represent some number, Y represent some number. You don't need to know what X and Y are right now. So we can say it has X number of cars, it has Y number of minivans, but they're all what different type of vehicles, okay? Now the company has at least 8 vehicles altogether. So bear that in mind. It has X cars, it has Y minivans. So it's that we have at least 8 vehicles altogether. It says the number of minivans is less than or equal to the number of cars. It says the number of cars is no more than 9. Okay, let me explain to you the basic concept now of this topic now, of linear programming, which comes under, of course, it comes under functions. First things first, this is what you need to understand. So I'm trying to find my marker. So this is my marker. Normally I'm not seeing the marker at all. I normally see the marker on the top here. I'm not seeing the marker. Here's the marker. No. Oh, Mrs. Johnson, I normally have the marker that I used to write. I'm not seeing the marker. I'm not seeing.
I'm trying to look as well on your screen.
Yeah,
Not
I
sure
normally.
what is
I used to
happening.
mark it always appear at the top here. I'm
Do you
trying to
want
see.
to?
No, because that's what I plan to write. I wanted to write on the questions itself. I wanted to show them what. Let's see what I normally use and write. I'm not seeing that. Let me see if I can use this. And I don't know. Well, I don't like to
Yes,
write
maybe you
this,
can
but
use this. What you're.
I don't like this. But all right. So what I want to show them is this. So ladies and gentlemen, pay attention now. Listen carefully now. So you need to get familiar with the words, and in terms of the words that CSEC we use. You need to know what you mean by minimum, So before I introduce to this question, like to form the inequalities, you need to know what does minimum means, maximum means, what does least means, and so on. Okay, so minimum, so make note for me, please. So when you hear minimum, ladies and gentlemen, minimum, this is writing very badly anyway. So the word minimum, I think I can write with this one instead. Let me say something. Let's see here. So the word minimum means what? Well, if you're saying that I must pay a minimum of say $5, what are you saying? So when you hear the word minimum, it can be what? If it's a minimum of say, for instance, $5, it can pay what?
5 or more.
Excellent.
5 or more, sir.
Well said. Excellent. So make note of me, guys. So minimum means what? At least. Minimum means at least. Don't forget, no, it not because I said the word minimum mean lesser or lower or no. Don't associate minimum to mean smaller, not or less than no. So if you say I want to pay a minimum of $5, so if you go to JPS and JPS say that in order for you to still have your electricity, you must pay a minimum of $5. They say you can pay 5 or more. So it means at least. Make note of that word. Okay. What about maximum now, guys? If you hear the word maximum, what does it mean? Maximum means what? If you can pay a maximum of $5, what does it mean? You can pay what?
At most. At most.
Excellent. You can pay $5 or what or less. So you can pay what? What does it mean? At most. Very good. At most. Excellent. Cool. And of course, we know what at least means. Having said at least, if you use at least as well, at least, what does at least means? At least means minimum, that or more. Yeah, that. At least $5, it means $5 or more. At least $10 or more. So it means that or more. All right. What do we mean by no more than? Well, no more than. So these are the words CSEC love to use. No more than.
That or less.
It means that or less. Excellent. What a very bright group, Mrs. Johnson. Oh, they're very, very on the ball, man. On the ball. I like that. Cool. All right. So we can go now to the question now. So make note of these words. And there are others, as time goes by, you will eventually learn them. All right. Take a picture, whatever you need to do fast. It says now write down 3 inequalities in terms of, so it's x and y or y, other than x greater than or equal to 0 and y greater than or equal to 0 to represent this information. So they're asking for 3 inequalities, guys. Let me ask you a question now. So you read the question from the beginning again. A rental car has X cars and Y minivans. The company has at least 8 vehicles altogether. Who can form the first inequality for me? It has at least. Don't forget now. So minivans, cars, which are vehicles, it goes with what? That's what? Quantity. So quantity goes with quantity. Money goes with money. The number of people go with number of people. So what is the first inequality? Now, what is an inequality? You must have either less than, greater than, equal to, less than, equal to. So what will be your first inequality? Who can tell me? When I add up the number of cars, this might say the company has at least 8 vehicles altogether. So if I add up number of cars, which is X plus, because they told that, we call X what? It has the number of cars, which is as X cars. So if I add the number of cars, which is X cars, plus the number of minivans, which is Y, what must be true? It must altogether be what?
48.
Yes.
Is it greater than 8? Is it less than 8? Is it less than or equal to 8? Or is it greater than or equal to 8?
I'll leave it.
Can I equal to it?
Which one is it? What did we say?
Less than
What did we say? Guys, listen carefully now. We mentioned about at least a while ago. What does at least means again?
That are more.
So that means x plus y must be what?
Greater than or equal to 8.
Greater than.
Are equal to?
8.
8. Very good. That's it. Okay, excellent. So first inequality is x plus y must be greater than or equal to 8. All right. That, well, you know, my greater than equal to, because I don't know how to write it in that thing I'm using. So that's why, but you know what to write it the way that you normally write it, which is this, of course. So you'd have add, of course, you'd have add x plus y is greater than or equal to 8. Okay, that's the first one. All right, cool. Next one now. You read, because so far, guys, everybody understand why we got x plus y must be greater than or equal to 8? Why we choose greater than or equal to? Everybody say why?
Sir.
All right, very good. It says now, the number of minivans is less than or equal to the number of cars. What is our second inequality? The number of minivans must be less than or equal to. What do we represent minivan? What do we represent minivan by? Minivans by?
Y.
Yeah,
Why,
no,
why?
minivan. Yeah, must be less than. So it
Y?
means that, yes, so it's y must be what? So it says it. It says it. You know, it says it. It is self-explanatory. It didn't go around in the corner. It told in words that
It is
less than or equal
equal.
to. Exactly. So it literally tells you. So it's less than or equal to. Is it x? Is it that?
That would be 8.
No, it's no. It says the number of minivans is less than or equal to the number. No, it said the number of minivans is less than or equal to the number of cars. So it means that x must, y is minivan, so y must be less than or equal to x. Come again, y must be less than or equal to x. Everybody appreciate that?
Yes, sir. Yes,
Good,
sir.
good, very good. All right, if you don't understand, please stop me. But it asks for 3, so we need one more. The number of cars, so each sentence, give me an inequality. But apart from the 2 first sentence go as 1. The next sentence says, though, the last one says, the number of cars is no more than 9. What is our third inequality? No more than 9.
X.
Come again? No more than 9 would be what? The number of cars is no more than 9. It would be?
X plus y less than or equal to 9.
Right.
Less than. No. Listen, man. No, man. It didn't say that. It said the number of cars is no more than 9. What represent cars?
X, sir.
So X must be. X must be
Less than or
Less,
equal
less
to
than or equal.
less than or
Oh,
equal to.
9. Well said. Please. All right. So please, guys, after you actually answer, please mute your mic. So well said. So it's x must be less than or equal to 9. And those are our 3 inequalities. Everybody appreciate that?
Yes, sir.
Okay.
Yes, sir.
Any question? All right. Please transcribe or take a picture, whatever you need to do. All right, now. Okay, so part B says a car can carry 4 people and a minivan can carry 6. So we're talking about now what? The capacity, okay? So guys, so think about it properly now. Capacity. A car can hold 4 persons, so it can hold or can carry 4 people, while a minivan can carry 6. Okay. But we know from, don't forget, it's the same question about a different part. What do we use to represent cars again, guys?
X, sir.
Excellent. What do we use to represent minivan?
Y.
Right. So what do you think they're saying then? A car can carry 4 people and a minivan can carry 6 people. So when I add the number of what? It said there are it said there are at most 60 persons to be taken on a tour. So guys, think about it practically. There are 60 people, 60 persons to be taken on this tour. But a car can only take 4 people. and a minivan can only take 6 people. Think about it now logically, guys. Think about it. So what would be our inequality? Forget about what the axis show. We don't reach that part yet. So let me just block out this now temporarily to show that, guys, I'm not really concerned about this part right now. Let me block it out temporarily. We don't care about this part yet. Hope you guys see me blocking it out temporarily. So if it can hold 4 and 6, I will call X the number of cars and Y the number of minivans. And there are at most 6 persons. Who can tell me now, form that inequality to link up the 6 to get together? Form that inequality. It has to be an addition of both things together. When I have the cars times the number of people that are in that car, the minivan times the number of person in that minivan, it must be what? It must be at most 60. What does at most means? At most means that are less. So don't think at most means more. No, that's not how logic works. So at most means it can be that are less. A minimum means that are more. So at most behave like what? When you say at most, you're saying like a what? Not, it must what? Not exceed. Not exceed. So what would be your inequality? Who can tell me?
Sir, it would be 4x
Excellent. Yes.
plus
Plus 6y.
6y
Yes.
less than or equal to 60.
Well said, my friend. Give her a thumbs up, or give them a thumbs up. Well said, my friend. Well said. Excellent. And then now we can look at what this must show now. Let's see what the show is saying now, guys. Now, so you cannot sort, guys. You have to understand the concept. You cannot sort. Everybody saw where this inequality came from? That's how it came from?
Sir.
What do you think they did? Why think they did to get 2x plus 3y less than equal to 30? What do you think they did?
They divide
Divided by what?
2.
2.
I would have said to my students, I would say wicked. after my time online, guys. And I'll be recorded. But normally I would say wicked. Well said. You divide through by 2. Let me talk to you about this now. Pay attention now. We only can divide through by a number. Listen carefully. We only can divide through by a number if we have an equation or an inequality. We cannot divide through by a number if it was an expression. Yes. If there's no equal sign, if there's no less than sign. So for instance, what I'm saying, ladies and gentlemen, if I had only 4x plus 6y alone, come again, if I only had 4x plus 6y, I cannot divide through by anything because it's an expression. We only can divide through by a number if you have an equation or an inequality. That's why now if I divide through by 2, what do I get? Come now, pay attention now. So we divide through by 2, what do we get? We get
X plus 2y.
excellent. All right, very good. And we got actually what they're asking us to show. Any question about that one? Everybody saw where it came from?
Yes, sir. Please start it.
Okay, very good. All right. Please transcribe, take a picture, or whatever you need to do. All right. I think I need to, let me see if I can remove these things
Sir,
now.
excuse me. So what
Yes.
it's saying, once there's an equation like 2x plus 3x, once they have the equation, you divide.
Yeah, you only can divide.
Okay.
That's if you need to divide. That's if you need to divide. If you need to divide. If there needs to. Because if there's no need to divide, then you can only divide. But only if you need to divide for whatever reason. So for convenience, and the reason why we divide through by 2 is based on what they asked us to prove. If they didn't ask us to show anything, we could have left it as it was. We didn't have to divide through. But for convenience, because it says show that, we want just divide through by 2. I want to just delete it to make sure that it's not, this writing will not be there anymore. So I just want to make sure it's not there anymore. All right, let's move on now to the next page now. Okay, all right, here comes the graph. It's a On the grid below, plot the four lines associated with the inequalities in A and B. Okay, all right. Now, don't forget, ladies and gentlemen, let me write what we had again now for you to remember what we're working with now on the same page here. So what we had initially was, what was the first one? It was x plus y was what? Was greater than or equal to 8, remember? Next one was y was less than or equal to, was it y or x? What, y? Less than or equal to x? That was next one. Next one was
Y
x.
is greater.
It was y is less than or equal, or what was it? Was it
X is greater than or equal to 9.
X less than or equal to 9.
okay? No. Is my second one correct? Was it y less than or equal to x? Or is that correct?
Yes, sir.
Because
Yes, sir.
if I don't then write the graph, will it be incorrect? I have to make sure it's correct. And next one is 2x plus 3y must be less than or equal to 30. Now, ladies and gentlemen, please pay attention now. Pay attention. Now, listen carefully now. As you can see, you're asked now to plot the 4 lines associated with the inequalities. No, because these inequalities can form what? Straight lines. Who can tell me why? How can I make these inequalities? Because you cannot plot the graph of an inequality, by the way. Let me explain this to you carefully now. You cannot plot the graph of an inequality. No. An inequality shows you in terms of what? The region. We only can plot the graph of an equation. So what you have to do, all these can be straight lines if you make it equal to. So temporarily, ladies and gentlemen, listen carefully now, pay attention. I normally say that the student who listens the most learns the most. So we're going to plot the graph of x plus y equal to 8. Note for me, please. Note for me. We're going to plot the graph of what they say. X plus
X plus y
8,
equal to 8.
8 plus y equal to 8. Leaving out the less than or equal to temporarily. Just to explain what it is. We're going to plot the graph of y equals x. Next one, we're going to plot the graph of x is equal to 9. Make sure I'm not writing on anything wrong, because my things will not be correct when I'm doing my solutions. It will not be correct when I'm looking at the other parts that follow. So make sure I'm writing on the correct thing, please. And then 2x plus 3y must be equal to 30.
Third.
Everybody appreciate that?
Yes, sir.
To go. All right, let's go now. Pay attention. Come now, Genesis, walk with me. Yes. All right, come Genesis, walk with me now. Pay attention. Now, who can tell me what is the graph of x plus y equal to 8? It's a straight line. How does the line look? Well, listen carefully now, because it's a sketch. It's a sketch. Listen carefully. Wait, it really is a plot. Plot means that it has to be accurate. Yeah, plot is different from sketch. When CSEC use the word plot or draw, it means it has to be accurate. Okay? Sketch means it doesn't have to be accurate. So let me stick to what they say. They say plot. So no, because if you realize that these are all straight lines, everybody agree these are all straight lines. Agree? Straight lines?
Yes, sir.
Yes, sir.
Yes? No.
sir.
X plus y equal to 8. We just need to use 2 convenient points, guys. Don't waste time. We just need 2 convenient points to plot the graph of x plus y equal to 8. Can I tell what are the 2 convenient points? The 2 convenient points are, where does the graph cut the x and where does the graph cut the y? Come, guys. No talking. Mute your mic, please, guys. If you're not going to talk to me, please mute your mic. Only when you're talking to me, open your mic. We're going to plot the graph of x plus y equal to 8. But because it's a straight line, we just need to know 2 points. What are the most 2 convenient points, ladies and gentlemen?
X and
Where does
Y.
it-
X and y.
X and Y. X and Y.
You
1
mean x
point
equal
on X and 1 point on Y.
You mean x equal to 0 and y equal to 0? That's where the graph cut the x and where the graph cut the y.
Excuse me, sir. Someone in the comment is asked if we can go back over.
No, from where? Go over where? From which part I must go back over?
I guess it's before you plot the when you do the
Inequality?
Right. I guess.
You really want me to come back over the equality? It's now 2 after
Not,
6.
not me, sir. Not.
No, I didn't say you, Satan. The person who asked, because I have a lot of things to cover tonight before we leave, or this afternoon, this evening before we leave. So I think I will go over if I have the time. All right, because I want to finish everything that I plan to do tonight or this evening. So, ladies and gentlemen, come now, walk with me. All I'm saying to you is this: it's a straight line. Just know where the graph got the x and where the graph got the y. Those are the two most convenient points. Now the graph got the x-axis where y is 0. Listen carefully. The graph got the x-axis where y is 0. Vice versa, the graph got the x-axis where y is 0, and vice versa, the graph got the y-axis when x is 0. So if I want to know where the graph got the x-axis, I literally replace y equal to 0 in the equation. Come now, pay attention. Come again. X plus y equal to 8. To sketch that graph, or to plot that graph, I want to know where the graph cut the x and where the graph cut the y. The graph cut the x when y is 0. The graph cut the y when x is 0. Who can tell me why? No, well, I already asked it's a rhetorical question. I'm going to answer myself. Let me tell you why the graph cut the x where y is 0. Can I tell you why? Because the equation of the x-axis is y equal to 0. Come again, Genesis, pay attention, you know. The student who listens the most learns the most. Come again, guys. The equation of this axis, which is what? The x-axis, is y equal to 0. Because every straight line can be represented by an equation. Vice versa, the equation of the y-axis is x equal to 0. Make note for me, no, very important for this concept here. That's why, that's why, if I want to know where the graph cut the y, I make x 0. Because why? Because the equation of the y-axis is x equal to 0, and vice versa. If I want to know where the graph cut the x, I make y 0. Why? Because the equation of the x-axis is y equal to 0. Everybody following me? Good to go? Okay, let's go now. So having said that, my friend, where does the graph cut the x-axis? The graph cut the x when y is 0. What will be the answer? So when y is 0, come now, ladies and gentlemen, please pay attention. When y is 0, we want to know where the graph cut the x-axis. It means that you substitute y 0 in the equation. When y is 0, replace y by 0. You get equal to 8. So the graph cut x at 8. Everybody see it? Everybody see that?
Yes, sir.
Yes, sir.
Excellent. Now, to know where the graph cut the y, vice versa, we make x 0. So when x is 0, ladies and gentlemen, you put it into the equation. Similarly, when x equals 0, you go to the equation. We get what? 0. That is x plus y equals 8. And again, so y would be equal to 8. So the graph cut the y at 8. You could tell me, you could have said, Mr. Morgan, I never need to do that. You could say, Mr. Morgan, why not put it in the form of y equal to mx plus c? Why not put y equal to 8 minus x in the form of what? Mx plus c, and the 8 would be the y-intercept. Yeah, I know I could have done that. You know, because the mx plus c, the c is the y-intercept, which is in this case still be your 8. But you know, you can do it as well. Okay, so because now it's a straight line and we have 2 points, we can draw the line. Can I draw my line now? I need to draw a nice line, guys, a nice straight line. Oh my Lord, help me. Help me, Lord. How am I going to draw the straight line here, God? That don't look like a straight line at all, but you get the point. So you're going to use the ruler, guys. Use a ruler and draw a straight line for me. Cool, all right. Mine don't look like a straight line at all, but you guys get the point. Now, next equation now, y equal to x. Who can tell me what y equal to x look like? Where does it pass through? Does it cut x and y axis? Does the graph of y equal to x
to the origin?
wait, Wicked. Well said, my friend. Well said. You're a genius. Well said. Passes through the origin. It does not cut any of the axes. It passes through the origin like a 45 degrees angle. I must can draw this one better now. Maybe it goes through like here. All of my I must can do a good job for this, ladies and gentlemen. Wicked. Ah, that's why I call it X. I need to label my graph. You know, let me label my graph. This is why I call it X. You must always label your graph in the exam. This one that I just did a while ago was what was X plus Y equals 8. Always label your graph. Don't assume that the examiner knows. Never assume. Now, who can tell me now the graph of X equal to 9? What is that graph? It's going to be what type of line? What type of line is that going to be?
A line going up from 9.
Is it slant? Is it horizontal? Is it vertical? What type of line is it?
It's
Vertical.
vertical.
It's a
It's
line which
vertical.
causes. Oh my! I can't even draw a straight line. What happened to Mr. Morgan today? What happened to Mr. Morgan tonight? What Mr. Morgan really do? What me really do? What me really do, guys? What me really do? It's a line that passes through 9, as it has to be what? Vertical, of course, as you said. So it passes through what? 9 all the way up. I don't know. My hand is not doing this thing right at all. Make sure you do it good in your book, by the way, guys. Do it good in your book. All right. So this is 9. It should be a straight line, guys. Just do it good in your book. All right. This is X equals 9. All right. And last line now. 2x plus 3y. Wait, the number gone. Equal to 30. The number is gone. 30. Should be 30, right? No, that line now is very tricky now, guys. This is careful now. You can make y look at the formula. You don't have to do that. That's not necessary. What are the two convenient points? We know where the graph could x by making y equal to 0. Vice versa. Know where the graph could y by making what? X equal to 0. Now, if to know where the graph could x, you make y 0. I'm looking at the last equation now, guys. The 2x plus 3y equal to 30. Come, guys, please now pay attention. So when x is 0, we're going to know where the graph cut the y-axis. So we're going to substitute 0 in the equation. When x equals to 0, we get 2 times 0 when x is 0. Plus 3 times y equals to 30. We're going to solve the equation for y. So what? 2 times 0 is 0. So we get 3y equal to 30. What is y? Is it 30 divided by 10? By 3? So is y 30 divided by 3?
Equal 10?
Yes.
So it's equal to 10.
Yes, sir.
Thank you. What have I done a while ago, ladies and gentlemen? I set x to be equal to 0. Now the mere fact that I set x equal to 0 is to find where the graph cut the y-axis. So the graph cut the y at 9. I mean, I'm a liar. At 10. At 10, I mean, not 9. Cool. Now to know the graph now, cut the x now, I make y 0, vice versa. Come, guys, pay attention now. The student who listens the most learns the most. The graph cut the x with y 0. So again, I go now to the equation and replace y by 0. When y is 0, what is x? We get 2x plus 3 times 0. 2x plus, because y is not going to be 0.
15.
We're going to go to 15, of course. Excellent, very good. So 0 is that, and then we get x equal to 15. No, I should have a 30 here. I meant 30, sorry. I put the answer by mistake. 2x equal to what? 30. X equal to 30 divided by 2, which give us what? 15. Thank you. It's a nice line. Oh, can I draw this line, guys? Oh, my God, can I draw this line now, guys? Let me see if I can do a good job. Oh, help me, Lord. I'm going to go like this. Oh, this drawing line, guys. Should I do this first, like that? Should I join like that, guys? Did I do that? This is not going to be a good line for me, guys. I don't know. It's not going to be a good line. Oh, I tried my best. Okay, I really tried my best. This is going to be 2x. I cannot write with this marker at all. This marker is not really. I never banked. I was looking for the marker and I'm gonna write with, and I do when I teach Zoom on Zoom and I see that marker that I'm gonna write with. I understand. I don't know what platform is this. All right. So I have done my 4 equation. Now, what the question do now? The question says that now, plot the 4 lines associated with the inequalities. Okay, cool. All right. Take a picture, guys, of the 4 lines. Make sure in your book you use the ruler, guys, and just do the thing properly. You know, so it cut it at 10 and what? 10 and 15. So just put the ruler at 10 and 15 and draw a nice line. Don't look at my not so wonderful line. Not so wonderful, but you get the point, okay? You guys get the point?
Yes, sir. So when you plot it, you're supposed to write the numbers where you plot them.
Yes, where it cut the X, where it cut the Y.
Yeah.
Because the reason why I only found 2 convenient points is that to do a straight line, we just need 2 convenient points. Know where the graph cut the X, know where the graph cut the Y. And I told the concept. To know where the graph cut the X, you make Y 0. You literally replace Y by 0 in the equation, and you get X equal to a number. To find where the graph cut the X, you make Y 0, right? And to find where the graph cut the Y, you make X 0, and you get what? You get Y to be a number. And then that's it. So, guys, so you've got your 4 lines. And now, but listen, we're not finished yet, by the way. The things that we were supposed to do were the inequalities. Don't forget, guys, it were the inequalities, not the equation. Who can tell me why did I draw the graph of equation? Who can tell me why? Why did I draw the graph of the equation and not the inequality? Who can tell me why? I know I said it earlier.
Because I'm on a straight line.
We cannot, you guys, you guys not listen to me now. We cannot draw the graph of an inequality. No, only of an equation. We use the inequality to know the region. So having converted my inequality to equations, they're all equations. Now we're going to decide now which part to shade. Because the inequalities is a region, it describes a region. So the inequalities, are just region it represent. The graph are drawn from the equations by making it equal to. I replace all my inequalities by an equal sign in order to do what? To facilitate drawing the line, the graph, which is a straight line. Because we only can draw the graph of an equation, not an inequality. Now we're going to look at inequality and now see which part to shade now. So guys, make sure to go to your book and everything ready now. Everybody ready now? Let's look at the first inequality. So having drawn the graph of x plus y equal to 8, we're going to decide now where on the line do we shade. Do we shade above the line or below the line? Let me use a different color now to shade now. So guys, make sure you're doing properly in your book. Let me use purple to shade purple. All right. Let me know. Where is x plus y equal to 8? No, x plus y equal to 8 is what? Is on the line. Agree? Is on the straight line we just draw. Where is x plus y equal to 8? On this line here. Which line? This line. See it here? This line. Everybody agree?
Yes, sir.
Yeah, that's a line, yeah. On the line is x plus y equal to 8. But listen now. For it to be greater than or equal to, now let me show the trick now, guys. Look here now. If a line is like this, look at this. If a line is like that, if a line slopes in that direction, greater than would be above. Don't forget, never forget this concept. Less than would be below. Yeah, that's it work. Yeah. So the mere fact that it is greater than or equal to, you shade where? You shade where?
Above.
You shade above. You shade above. You shade above. Very good. Shade above. Shade above. Shade above. You keep shading above. You keep shading above. You realize what I'm shading? Which line am I shading from? I'm shading the what? X plus y what? Greater than or equal to 8. Which I use that equation to represent. I use the one where it's equal to. But above that line is where it's greater than or equal to. On the line it's equal to. Above it's what? Greater than. Below it's what? Less than. Everybody following me? So this is where it's greater than. This is where it's less than. Make note for me, please. Cool. Now, at some point, we're going to have to erase some of those shading now. We have to erase some of them eventually because all this linear programming works is that after you keep shading different lines, you're going to close up a bounded, it's going to be bounded by what? By lines, and you're going to reject the part that you don't want. So the one that you want to choose is where all them chop at the same time. Like it chop by what? By 4 lines at the same time. That's the region, that region when you choose that correct region. You soon see what I'm talking about very soon. So we shade above for that one. So above the line would be what? Y plus X is, see there, you could even write it in a short. This is Y plus X is greater than or equal to 8 above that line. Cool. Next one now. Y equal to X is my line, but want to find Y less than or equal to X. Let me show one more rule, guys. Don't forget this rule no. Come Genesis. Pay attention no. Walk with me. Let me show one more rule you need to know now. Let me teach you now mathematics now. If a line then, on the other hand, slopes in this direction, which direction? Watch carefully. If a line slopes in this direction, this side is where it's greater than. Yeah, that's it work. Work like a charm. This is where it's greater than. Below is where it's less than. Yeah, that's it work. It works like a charm. So let's see now. Where's Y less than X then? I haven't said that. Where's Y equal to X? Y equal to X on the line. Everywhere on this line, Y equal to X. Where's Y less than X? Or equal to X? Where?
Below the line.
Below the line, sir.
Which is
Below
right
the
here. Not you, my friend, talk to me. Not you? Everybody
Yeah.
with me, follow me. Let me use a different color for shading now. Let's do a different color for shading. Let me use like say a green now for shading. So I'm gonna shade this now. So I shade like this. I shade like this. And you soon see what I do after, you know. At some point, I have to erase some of these shading part, you know. So I shade everywhere below that line. Cool. Next one now. X equal to 9. This part is obvious now. Where's X less? Where's X now what? What was that? Where's X less than 9? Everybody knows where. It has to be to the left or right of 9.
The left.
X, well said. Let's use brown. This is where X is less than 9. Come Genesis, walk with me. The student who listens the most learns the most. Okay, and lastly. Now the last shade that you're gonna shade, we're gonna close the region that you want. It's gonna what we call, it's gonna bound the region. And the line of what? 2x plus 3y less than 30 or equal to 30. Now where is it less than or equal to 30? Below or above?
Below, sir.
To the left, though. To the left.
Yes, sir.
Well said. Let me use a different color now. Let me use, let's use yellow. So we're going to shade this here. I would normally say school is now over. School is over. You know what you did a while ago? We're going to trap now the region that we want. Which region do we want? All right. Let me see now which region we want now.
Common region.
Exactly. The one that trapped by all 4 at the same time. Let me show what I'm going to erase now. Let me show what help me now to erase. Help me to erase. I need to erase this one, this part. Agree?
Yes, sir.
This is no man's land. Let's erase this part. This is no man's land. We need to erase this part as well.
So, sir,
this part is no man's.
Yeah, try to find it out where will I line in class too.
Hey, we satisfy all of them at the same time. Which satisfy all of them. Very excellent. Which satisfies all inequality at the same time.
Right now, make a listen.
So it's exactly because one line send it back that way, the other one send it back that direction. So one that trap all of them at the same time. We're trying to find the common one. Excellent. Let me see. We don't need to do this one either. Because I want to bring it back upstairs. So if you erase this part here, let's see what we're gonna John shop. We need to erase. Let's see now. This one bring it back upstairs. This one bring it back downstairs, and this one bring it to the left. And then this we need to erase this one as well. We don't need this one as well. This one is gone. You know why? You know why? By virtue of the fact that the one about x plus y, sy greater than 8. goes all the way upstairs, so we don't need this part here. So, and this line now bring it back downstairs. So let's see what I want to choose now. I want to choose where it's, let's see now. I want to choose this part only. Let me see if I can show which part I chop all of them at the same time. Guys, you need to look, you know. You must not only look, you must see. And now I'm student, you must not only look, you must see. You must see. We don't want this one either. No, we don't want this one either. Let me see, can I undo this thing here? Can I undo it? We only need this part only. How do I undo this thing here? I don't even know how to undo it. What time is it now? We only need what? Right here. The one with the 10 on this one had gone this way. Wherever it had gone. So we only need this region, guys. This region. Everybody appreciate that? Everybody see it?
Yes, sir. Got every line part through this one.
Yeah, so it actually send it back. It send back everybody to that direction. So one line bring it back up, one bring it back down. So that one is where I love where you said. I love where you said. Every line passed through that one. Very good. You said the right way. Yeah, excellent. Thank you. Cool. All right. Now, guys, no. Can I ask a question now? At those four regions, we could label them A, B, C, D. Because what CSEC love to do now, CSEC can ask about minimum, maximum profit. Or they could say, what's the best part that give the maximum profit or minimum profit? So what you can do, we can label it. So let me show you what to do now quick, guys, before we change the page. Label them as A, B, C, D. Let me see how many points we have here now to label now. Come, guys, help me now. This is, now where they all intersect, label this one A with a cross, B, C. Well, these two don't intersect in it. Oh, this is just one thing. Well, this is one point and it is really D. This is like a trapezium. All right, let's call this D here then. This and then this part here E. Yeah, this is also one line. Because they didn't join us one line. They do those two lines meet? Do they meet, by the way? X equal to 9. Let's see, X equal to 9. They actually meet below, which that's a part of the graph. All right, cool. All right, I don't want to jump the gun. I need to know what CSEC asks below. Let me not jump the gun, guys. Let me see what they ask first. Take a picture for me. Let me erase what you don't know. Not what you don't know. I said the wrong thing. What you don't need. Let me erase what you don't need. Because this look a little really untidy. I just want to keep what you really need. No, the question say initially it says apart from x greater than or equal to 0 and y greater than or equal to 0. What do you think those two lines are? What is the line of x greater than or equal to 0? Is it x and y axis? And those two lines are the x and y axis, where x and y, x is greater than 0 is above, y is what? X greater than 0 is what? Above, y is what? To the right. So those two lines are that they mentioned in your question. Those two inequalities are what? X greater than 0, which is to the right of x, above the x-axis, y greater than 0 to the right. So it would capture those two regions anyway. So I don't have to worry about those two, the other two. And then now let's look and see what they have downstairs now. All right, can I move on now and see what they have downstairs before I don't want to jump the gun still? Okay, cool. All right.
Yeah.
It says now, everybody, I don't have to go any further. I can just do that one now quick. It says now, determine two combinations for the minimum number of cars. I know they would have asked about that now. Minimum, yes. Now, don't forget now, our initial equation that we had was what? Was the 4x, it was a 4x plus
6y
equal to 60.
Right.
Yeah, let's write back that equation. Yeah, that was the initial one we had. Let's write it back now, guys. Come, guys, please pay attention now. We're going to use that to get everything we want now. So it's 4x plus 6y. And that was equal to 60. Okay. We're going to use that one equal to 60. Don't forget that equation when we work with that one. So determine two combinations for the minimum number of cars and minimum. So we just make it equal to 60 now, guys. All right, not less than equal to, or it's just equal to 60. But listen now, guys. We need to know now the point to choose now. Let's see now. What point are we going to choose now? Let's go back to the graph and see now. This is where you need to know, guys, what's going on here now. At the point, so we have 4 points. No, let's see. How many points do we have to choose from? We can choose this point here, guys. I need to know what this point is now. Could I find this point here? Who can tell me what this point is? Y equal to x coincide with what? With what? I need to know what this point is, guys. Let me point on what I'm saying. I need to know what this point is. What point is that? What point is it? Is it that's where the two lines meet? We can equate the two equations, right? Where both of them meet, we can equate the equation. What does that mean? Because at the point of intersection, they have the same x and they share the same y value. Because mine graph not drawn properly, let's equate them and find it, guys, manually. So what we have was what? It was y equal to x. And that actually crossed with what? With x plus y equal to 8. So we can replace x by y, y by x, not true? So if x and y are equal, what is true? So if x equal to y, we can call y plus y equal to 8. So 2y equal to 8. Everybody see what I'm doing? Y equal to 4. So that means that there should be 4 right here. And then if y is 4, x is also what? 4. So the point A is 4, 4. Am I right? Guys, you don't see what I'm doing? Everybody see what I'm doing? You guys follow what I'm doing? Who see what I'm doing?
Sir, where you get the 4 for, sir?
All right, because at the point in which the two lines meet, at the point of intersection where the two lines meet, I want to know what x and y value they actually share. So if I equate the two equations, because this equation is x plus y equal to 8, this is x plus y equal to 8. This one is what? Y equal to x. See there? So I equate both of them. Because y equal to x, you know. So if I want to know the point of intersection of two lines, you make the two y's equal to themselves or make the two x equal to themselves. So we equate the two equations. So if by virtue of the fact that I make y equal to x or x equal to y, because I want to know this point, I want to find the point of intersection. I want to know what this point is. Because to find what the axis, we need to know what these points are all. And we're going to put them in the function to see which one give us the minimum number. That's what you want to do. Which one give us the minimum number, or whatever they ask for at the time. Because it asks for the what? What did the question ask for? It asks for the number of the different combinations that we want to find. So you want to know how many cars and how many minivans are the total number of vehicles that you must get. You know? So we have two different combinations we can use. Are different. So what combination you want to choose? What combination? You can choose that point here, or you can choose this one here. You can choose this one here, or you can choose this one. So if I look at the one with B now, what line is B? The point B is what? X equal to y, and also what is equation this line here? That line is what? Was 2x plus 3y equal to 30. X equal to y. So to find where B is now, we actually equate those two again. So replace x to y in the equation. When x equal to y, what do we get? We can replace x by y, y by x. We can get 2y or 2x equal to 30. So guys, I'm trying to find the point of intersection of the two lines. To find the point of intersection where the two of them intersect, okay? So we get 5y equal to 30. Because x equal to y is the equation, and what's the next equation? 2x plus 3y equal to 30. So I want to know what they meet at what point? They meet at B. So I want to find the coordinates at B. So y is equal to what? 6. If y is 6, x is also 6. So the point B is 6, 6. That's one more point. Cool. Let's find the point C. But I know what point C is now. The point C, x is 9. Everybody see why x is 9? At C, x is 9. But what is y? I can find what y is. When x is 9, what equation do I use to find to find y when x is 9? What equation can I use to find y when x is 9? What equation? To find what the point C is. What line does what two lines meet up? The line x equal to 9 meet up at what? Which line? 2x plus 3y equal to 30. So if I want to know the point of intersection of the two lines, I can equate them. X equal to 9, and what is the next one? 2y plus 3y, 2x plus 3y is 30. So I'm going to replace x by 9, so you get 2 times 9 because x is 9. So I put 9 in the equation, 3y equal to 30. Come Junior says, no, guys, don't worry about it, guys. Take it easy, guys. Don't get stressed out now. I know this is kind of, it's like I start losing people now. People not answering me anymore, but don't get stressed out, guys, step by step. All right, Rome was built in one day. So we get 18 plus 3y equal to 30. I'm just trying to find where the two lines meet. That's all I'm trying to find by equating the two things together. Then is 30 take away 18 is what? Is 18. So y is what? 18 divided by 6 is 3 is what? Is 6. Yeah, so this is 6, 6 as well. No, it's 9, 6, 9, 6. So C is 9, 6. X is 9, Y is 6. Yeah. I don't think I need anything more. I don't think I need anything more now because it asks for the two. Let me read back the question. That's what the question asks again, guys. Let me make sure I'm not going on that. It says, determine the two combinations for the minimum. Okay, number of cars. All right. So if I use now the minimum number of cars. So let's see now which one gives us the minimum number of cars. Everybody see what I'm trying to do? I'm trying to find the region that we actually shaded, is the region that we are focusing on only, which is A, B, C, D, E. Everybody find what I'm trying to find? So I want to know now, what is the minimum number of cars that we need to do? So if I have 4 minimum of cars and vans. So from this equation now, we're going to put these points in there now and see. So at point A, what was X? Let me know. X was 4, Y was 4. Y was 4. So you have 4 times 4 plus 6 times what? 6 times 4. Do you get 60? Do you get back 60? No, that you can't choose that point. No, you don't get back 60. Right? Everybody following me? That one don't satisfy the equation. Let's do the next point now. What was B again? 6 and 6. Let's try point B, 6, 6. Let's satisfy the equation, 6, 6. 4 times 6 plus 6 times y. Do we get back 60? Do we get back? This is 24 plus what? 36. Wicked, school is over. We get back 60. So we at this point, so that's a point B to be considered so far. Let's look at B so far. Okay, we get back 60. Cool. Which other point can we use again now? What is C? C is 9, 6. Let's try C, 9, 6. And so we get 9, 6. C is 9, 6. So which one satisfies the equation? So it is 4 times 9 plus 6 times what? 6 times 6. Do we get back 60? 9, 4 is 36. 6, 6 is 30. 6, 6 is 36. No, we get back. That give us 72. No. So guess what, guys? We can't choose that point. Let me make sure I'm saying the right thing. So if you have 9 cars and 4, I should have meant 9 cars. 9 cars. That mean, is it 9, 9? Is it 9? Is 9, 4? Hold on, am I doing the right thing? It was 9, 9. It was 9, 4, and 9, 6. Is it 9, 4, and 9, 6, guys? I'm losing the class. Oh my Lord, I don't think I like what's happening. You guys, Ladies and gentlemen,
Students, you're still on with sir?
you know what's happening? All right, you know what is true? Let me move to part 2 for the time being. This is part. Let me form. I think I will go back to it because I want to make sure I capture everything tonight and I can go back because I realize that I'm losing them and not feel the energy as I started out with initially. So let me look at part B, guys. I will go back to this eventually. Don't worry, all is not lost. Don't worry about it, guys. I just want to introduce the concept because every question is going to be different. Once you understand the concept, you're good to go. You can't swat. All right, let's look at. I want to form the equation or the inequality. Part 2 said the company charges $75 to rent a car and $90 to rent a minivan. Show that the minimum cost for this store is $990. So we're gonna form the cost function, guys. Because I mentioned about cost. What will be my cost function? Well, for each what? Car 75 and for each van is what? 90. So let's call the cost function C of X. Okay, ready? So let the cost function be called C of XY because it's two variables X and Y. So we're going to multiply 75 by what? By what? By X. Is it 75 by X? Is it 75X, guys? Yes?
Yes, sir.
Because X is, yes, and then cars is what? Plus what? 90 times Y. And that will be our cost function. Guys, this is a very important topic, guys, for linear programming. And this question is applicable if you want to know how to find the minimum cost, the maximum profit, or, you know, you want to minimize or maximize the use what is called linear programming. There's a course at university. If you come to university, you're going to do that course. It's a second year and a third year course. I mean, very, very good course, okay? And they can use this for game theory to choose them, you know, the best, like you do in a Pac-Man game, play a Pac-Man game, which is the shortest distance you must go on. It's applicable in life, in real life. Anyway, so I've been found the profit function. Now we're going to do the exact thing, guys. I said points I found a while ago. You're going to put in those points. You're going to put in the points I just found a while ago, guys. Let me tell you what will be the answer. It will be 9-4. Tell it from now, because I did the question already. 9-4. That will give the actual number. That will give the minimum rental cost because that will give a bigger number. When X is 4, no, it was X is 9. Sorry, when X is 9, Y is 4. So the cost, what point was that? 9-4, whatever the point was, 9-4. So 9-4 would give that 9. X was 9, Y was 4. The same area actually, we bound that area. The area we call ABC, we're going to use those points, replace it in the cost function, and whichever one give us the smallest amount of money, that's what we're going to use, okay? So because I did the question already, if you try the other points, they won't work. You get a big number. But this one give us the smallest amount of money. So we're going to replace what now? Help me now. So when you replace, so C then will be equal to 75 multiplied by X. X will be 9. Come Genesis, pay attention, walk with me. Times 9 plus 90, which is what? That times what? Times 4. And what you should get for the answer when you finish, guys, you get 675 plus, it should be 675. What am I doing? Oh, I did the wrong thing. Okay, sorry. 675. Oh, 90 times 9. Why is this not writing? So, guys, it should be 675 plus, let's go again. Oh, it is cutting off. It is cutting off. Oh, I just what's happening, guys. All right, I don't want to waste time, guys. I want to get the concept. The concept is important. So C would be 75 times 9 because X is what? 9 plus 90 times Y. Y is 4. And what you should get for the final answer, what I got is 675, which is 9 times that, plus 360. And the amount of money you should get now is $1,034. And that is the minimum cost. CXC love to ask this question on a linear programming. So you would have said to CXC that the minimum cost is $1,034. And this occurs when you have how many what? 9 cars and 4 minivan. And that's it. Okay? No, I might have said the wrong thing, you know. Hold on. No. No, that's not true. That's not true. No, that was the minimum one. Guys, I'm a liar. That was the minimum one. No. The minimum one was not that. The minimum one was what? With the one with 6, 6. No, I don't know where I talk. No, when X was 6, Y was 6. The point that got 6, 6, no, I don't know where I talk, that was the minimum. That was the minimum. I'm a liar, guys. 75 times 6. X is 6, Y is what? This one gave us the minimum. That gave us the maximum, not the minimum. That was the maximum. If I asked for maximum, you'd have chosen that one. But because I asked for minimum, so I did the wrong thing, sorry. 90 times 6. And that will give us now 450 plus 450. And then so the minimum cost was $990. $990. So this minimum cost occurs when we have 6 what? Car and what? 6 minivan. Yes. So you have to try all the points we just found a while ago. The points would what? Would be A, B, C, D, whatever. Those that you'd have substitute all those points in the actual cost function. And the one that gave us the smallest amount of money, that would have been the minimum what? The minimum cost. Okay. All right, guys. If you don't understand, don't worry, guys. All is not lost. I will try to go back over it again if I get the time. Let's move on fast to the others because the others might be quicker than this one. This one took a little while, I realize. Some questions are longer than some, guys. So don't have to worry about it. Some questions are longer than some. Take a picture for me quick. Take a picture. All right, so I want to make sure I delete these before it doesn't stay on there.
Akinki, I hope I'm pronouncing your name correctly. Your hand is up. You can go ahead, Achet.
Oh, there's a question? Yes. Yeah, question. You can ask me, you can always stop me, guys, intermittently and ask me any question you want to ask me while I'm moving. Yes, question, please.
Sir, excuse me. Sir, how you get the 6, 6 if you multiply them?
Let's go back again to the graph. Remember, I trapped the region. So what I did a while ago, guys, what I got when I actually sketch graph of the equation and I shaded the region that satisfies, because I've been sketch graph of the equation, what I actually literally did is to shade the region that satisfies the equation, the inequality, which is this, whatever, and we got something like that, okay? I will call it A, B, C, D, whatever. So let me show you what to do upstairs now. So you just identify the region that is trapped by all 4 at the same time, okay? See it right there, my friend? So, but we have to find what A is. The coordinates of A, where X is what? A number, Y is a number. And I showed you to find out, because my graph is not sketched properly. You know, you could literally read it off a graph. If you use a graph leaf, guys, and draw your lines properly, you could literally read off the numbers, you know. Yeah, man. So that was 4 and 4, but because I didn't sketch my line properly. If I don't have a proper sketch, then you have to equate the 2 equations to find out where they actually intercept. Solve the equation, and then the X and Y values are the points A. At A and B, similarly, you equate those 2 equations that form those 2 lines. So the one with the one with 9, 4, the one I mentioned about the answer, guys, come Genesis now, walk on, pay attention. The 9, 4 is what? This point right here. See it here? This was the point 9, 4. At C. X was 9. See it here? This is X equal to 9. Straight line, X equal to 9. And I replaced 9 in this equation. 2x plus 3y equal to 30. See it right here? And we see it here. And we got y, and y ended up being 4. This was not the one, this was a different one. Y was equal to 4, okay? For that one. So we have 3y, yeah, plus 2 times 9. 9 2 is 18. So we have 18 plus 3y is 30. And we bring over the 18. So we have 18. So if you remember what I did earlier, I bring over the 18 and we get 30 minus 18 is what? Is 12. So y equal to 12 divided by 3. So y is what? 4. So when x is 9, y is 4. This should have been 4, not 9, not 6. 4. Yeah, this must have been 4. This, yeah. That's what you're asking me? All right.
Yes, sir.
All right. If you don't understand, like I said, it's not lost. Some of the other questions might move very fast. That's a good thing. When I look at it, I realize that some of them won't take so long. I can always go back over it again because I still have time. Let's move on now fast, guys. because I know if by time I'm looking at it's 7:30 and I don't want to go over, as Mrs. Johnson had actually indicated earlier. Let's go to quick now to the next question fast. Okay, so let's see. This one might not be so long as I said. Okay, so number 2021, that was January, the reset in January 2021. Let's look at this paper now and see what it said. It says now, this is now, okay, this is called linear, coordinate geometry. It's called, guys, you need to know what topic are under each time. It comes in what is called coordinate geometry. Coordinate geometry, okay? It says a straight line, it of course come under algebra as a function. The straight line graph x equal to 5 minus 3 y intersect the x axis at P and y axis at Q. So guys, so technically speaking, guys, if you have a graph, what they're saying, guys, what they're saying really and truly, whatever the line is, when you sketch the line, everybody knows what this graph look like. Yes, we can make y the the formula. We can put the form of y equal to mx plus c. So if I bring over the y on the left hand side, I get 3y. And then bring over the x. That is if I make y equal to mx plus c in that form. So I replace what? I just replace it on that side, replace the 3y on the left hand side, x on the right hand side, and then 5 remain in this position. And I now make y the of the formula. So I put in the form of y equal to mx plus c. Cool. Come, Gina says no, pay attention now. Come guys now, stay with me now. So we know that the graph cut the y where x is 0. So what they ask now, it says, now look what they say. The straight line, they're going to have a straight line literally. How does the line look? Will the line look like this? Will the line be like this? Will the line be horizontal or will the line be vertical? How will the line be? How will the line slope? Which direction? Who can tell me? Can it be vertical? No. Can it be horizontal? No. Now the line of 5 over 3 minus 1/3 x, does it slope in that direction, or which direction does the line slope? Which one? What determines our line slopes, guys? What determines the slope of a line? How it slopes? How it actually slope? Slope means how it actually slant. What the slope means? How does it slant? What determines how it slants? Who can tell me? The gradient, right? The gradient.
The gradient.
Yeah, mx plus c. M is a gradient. Very good. Y equal to mx plus c in that form. See there? In that form, we have y equal to mx plus c. M is what? The gradient of the line. M tells you if a line is horizontal. If a line is horizontal, M is 0. That means there's no gradient. If a line is vertical, M is undefined. It cannot be determined. It's undefined. If a line is horizontal, vertical, there's no gradient. It cannot be determined. If a line is in this direction, where you say from lower left to upper right, M is what? Greater than 0, positive, because M is a gradient. If a line is in that direction, M is what? Negative. M is what? Less than 0. So how would my line look, guys? If this is my equation, how does my line look? What is M? What is M in my equation? In this equation, what is M?
0, 3.
Negative 1/3.
Negative 1/3, sir.
So will my line be this or this? Which one? The top one or bottom line? Which line is it going to be? M is what? Less than 0. So the line is going to be this, not true? So this is going to be my line.
The first line, sir.
Yeah, that will be my line. Not true, my friend? Talk to me. Not true? That will be the line. So it says now, the line intersects the x-axis at P and y at what? At Q. Right here, so. So if I find these 2 points, if I find those 2 points, school is over. The question done, school is over. How can I find it? How can I find the P coordinates? Who can tell me? What do I do? Let me make life easy now. What will be the y value at P? What is y equal to at P?
0.
Excellent. Excellent. Well said. I like that. Excellent. And how do you find X value? How do you find X value?
The number that is on.
How do you find X value? How do you find X value? I told you earlier.
Substitute 0 into the equation.
Substituted.
What is substitute? Substitute, you mean y equal to 0? Not you?
Yes, sir.
Excellent. Well said. Because you could mute the mic, please. Mute the mic now for me. The graph cut the x where y is 0. And we just saw y was 0. Excellent. So at the point P, y will be 0, obviously. Excellent. So when y is 0, come Junior says, no. Come now, let's bring to this conclusion. When y is 0, what do we get? Let me know. When y is 0, we get x equal to, let's use this equation, easier to work out. 5 minus 3 times 0, so y is 0, x equal to 5. So this is 5. Wicked. Everybody with me? All right. What about the q now? What about the point q? Now, what is the x value at q? What's the x value?
0.
Excellent. Because what does say? On the y-axis, x is 0. On the x-axis, y is 0. So if I want to know where the graph cut the y, I make x 0. So I replace what? In my equation, x equal to 0. Do what it says. So 0 is x equal to 5 minus 3y. You're going to make y the same as the formula. Make the y positive, but you can left hand side make it positive. Divide 2 by 3. Y equal to 5 divided by 3. School is over. And that's the answer. 5 divided by 3 is the answer. Okay? So the answer is, at P we have 5, 0, and what? Q is what? 0, 5 over 3. So you'd have put this here. The space is here already. You'd have put here then, guys. You'd have put 5 here. Yeah, and 0 right here. I'd have put 0 and 5/3. Okay? And that's it. Okay. 2 decimal place. Oh, that is part 2. I don't reach part 2 yet. All right, any question? All right, let's move on fast. Time is going. We have to bring this to conclusion fast, guys, you know. The other questions are relatively short. That's a good thing about them, not that long like the first one. All right, let's go quick now. All right. It says now, calculate the length of PQ. Guys, here comes the formula now, the formula for length of a line. How do you find length of a line? Maybe you can't tell, I don't have time let's go on because time is going. The length of a line is given by, let's call length L. What is it? The square root of what?
X2 minus X1.
Excellent. Very good. Excellent. So we got the 2 points. So x is 0.
Yes, sir.
And x is 5. So it's 5. So the difference in the x value subtracted. I mean difference and square it. Plus the difference in the y values and subtract them.
And square it, sir. And square it.
Excellent. And square it. And then school is over and you get the answer. That's why I'm saying 2 decimal place because I'm going to get decimal in the answer. So we're going to get 25 minus 0 is 25. Then plus, so 0 minus 5 over 3 is still 5 over 3. You get 25 over what? 25 over 9. Cool. All right. How we get for the final answer? Calculator. You can use the calculator and get the answer, guys, whatever the answer is, okay? You can do it and tell me the answer, calculator. 9 times 25 is what? And plus 25 divided by 9, and then you take the square root and what to answer. This is where the calculator work, guys. You what? You divide 25 by 9, add 25 to it, and take the square root and whatever the answer is, and put in 2 decimal place. Okay, whatever is the answer, okay? Anybody can try it now quick and tell me, or we can move on to the next question. At least you get the idea.
27.8.
How much you get?
27.8. No, for the answer.
You divide 25 by 9 and add 25 to it first. Divide 25 by 9. Add 25 and we'll take the square root of that of everything. Square root of everything. And what you say get? If somebody can try quick and tell me.
7.7.
How much?
7.7.
You get 7 point. You get 7 point. How much? 2 decimal place.
7.3.
3 what? What comes after 3? It's a 2 decimal place.
0.26, the 2 decimal places.
You run it off. What came? What before? It was 6. It was what before it became 6? It was 5 something, or it was 6 something. What was it? Give me 3 decimal place initially. 7.3 what? 3 what?
7.264. That's the 3 decimal places, but there's an 8 afterwards.
7.3 what? 3?
7.264.
Oh, so no, so it's 7.26 then, not 3.6. It's 2.6. Who's the 3? Well, guys, it's calculator work. It doesn't matter. It's calculator work. You can do it. Okay. Let's make sure you use the calculator properly, guys. Okay, and that's it. All right. So follow instruction. Okay, that's the length of the line. Okay, part 3 now says the midpoint of the line. Let's call the midpoint R. What's the midpoint of a line, guys? Who can tell me the x is divided by 2 when I add them?
X1 plus X2
So it's
divided
5
by
plus
2.
0 divided by 2, comma, that's the x value, and then y plus, what was it again? What was it again? 7 over 2? I mean 5 over 3. So we add the x values divided by 3, add the y values divided by 3, by 2 rather. What am I saying? Divide by 2. So what we have then, so because R is the midpoint, so the current is going to be what? 5 over 2, am I right? Comma, 5 over what? Is it 5 over 6, I think? Yes, 5 over 6, and that's it. Okay, make sure I'm right, guys. So the midpoint, add the x values divided by 2, the y values divided by 2. Because what was the line? The midpoint of this line is somewhere here now. We call it R. We add the x, so it's 0 plus 5 divided by 2. 5 over 3, so see that is 0 plus 5 divided by 2. We add x divided by 2. Then 5 over 3 plus 0 divided by 2. And we get 5 over 2. So it becomes 5 over 2, comma, 5 over 6. And that's the midpoint. Okay. Any question? All right, let's move on now. Different question now, guys. So we're moving on. All right. All right, let's see now quick. All right, that's want to erase what I don't need because I don't want it to stay on the thing and don't come out. All right, let me know quick, guys. Now we will move on to the next question now. Quick now. I don't know why this thing, I could have delete all. Yeah, I don't understand this thing at all. What's going on here? Anyway, let's move on. I'm using the same page to write, so let's move on. All right, cool. It says now, here comes now, guys, functions and relations now, guys. Next topic now. All right. The function, how do you read this now? It says f is such that, the colon is read as such that. It's a, how do you read this first one, guys? It says f is such that it maps what? Help me know. This one. F is such that it maps what? It maps what?
Sir, f of x equal 5 minus x.
No. How do you read this? F is such that it maps what? It maps what? It maps what? X to what? 5 minus x. That's how you read it. G is such that it maps what? X to what? X squared minus 2x minus 3. So what we're saying in effect then is that f of x then is given by 5 minus x. That's what it's really saying indirectly. And then you call it g now of x is given by. So both of them are a function of x. Cool. It says now, both of them meet at m and n. So we have a straight line and we have a graph, okay? We have a straight line, guys, like this, and we have a graph like this, not true? So they meet at what? They meet at m and n. I don't know what the graph look like, and I don't really care, because they never asked about the graph. They didn't ask about the graph. I'm just trying to show a little situation with what the graph will look like. So to show the idea. So the line and the graph, they actually intersect at what? 2 points. How can I find the point of intersection of a line and a graph? What do I do? What's the concept? At the point of intersection, what is true? They are equal, right? What are equal? They share the same x and the same y value. So I'm going to equate the two equations. So I'm going to equate f of x equal to g of x. Because why? The only time they share the same x and y value. This is come Genesis, let me teach you mathematics now, walk with me. The only time they share the same x and y value, they only share that at the point of intersection. They share the same value. So to find the x and y value at the point of intersection, you equate the two equations. You make them equal to each other. So that means that, what does it mean? It means that 2x squared, then you equate them. X squared, pay attention now, minus 2x minus 1 going to be equal to 5 minus x. Cool. Solve the equation. It is what? Quadratic. Is that you guys are familiar with this equation? It's called quadratic. The highest power is 2. How do you solve that equation? Bring everything on one side and make it equal to 0. Everybody with me? You bring everything on one side and make it equal to 0. Because I cannot teach everything in detail. I don't have time to teach you in detail. But you must always put it in the form of ax squared, put it in that form, plus bx. Always put in that form. You bring everything on one side, make it equal to 0. That's how you solve all of them, okay? All those equations with the highest power is 2. You make everything equal to 0. Bring everything on one side. Then when you combine like terms, come Junior says, what do you get? You get x squared minus x with a combined like term, minus 6 equal to 0. That can be factorized. Guys, go back over factorization. That is x minus 3 when you factorize times x plus 2. And that's equal to 0. Then now school is over. We can now find x values. So x equal to 3 or x equal to minus 2. How do you find y values now? What do we define y values? We can replace those x values in what? Any of those two equations. We get the same answer, right? We get the same, right, guys? Because we can call the function y. Y is called a function. Y is called a function. So to find the corresponding y values, when x is what? 3, you can use any of the equation above, you get the same answer. If you use this equation, when x is 3, what do we get for y? Y equal to 5 minus 3. So y will be equal to 2. When x is equal to minus 2, again, similarly, when x is equal to minus 2 is the same equation. When x is minus 2, 5 minus 2, which is what? 5 plus 2, which is 7. So what are my my points of intersection? What is M and N? What is M and N? M is a point what? What is M? M will be what? Minus 2. When x is minus 2, what is y? Minus 2, 7. So what will be M? Come guys, come Genesis, walk with me. What are the coordinates, guys? The coordinates of M and N? I just put it a while ago. When what? When x is minus 2, y is what? 7. And when x is what? 3, y is what? 2. And that's it. Okay? Any question about this, guys? Any question about that? Everybody saw get that? Okay, you just equate them, you make the two of them equal, you solve the equation. It is a what equation? Quadratic. It can be factorized, okay? All right, please take a picture for me quick. So guys, go back over these guys, go back over to find whenever you have 2 points intersecting or 2 graphs intersecting, make sure to find the intersection points between them, and make sure you go back over factorization of the quadratic expression or the equation. Please go back over that, guys. It's normally a standard question in CSEC, a standard question in CSEC. It always comes, something like that always comes. We have to factorize. Okay, let's move on now, quick now. We're bringing now to this conclusion now, guys. As I said, we don't have much left to do now. So we can go back to number 1, hopefully. The first question. This is really relatively short now. All right, let's move on now to the last. I think this will be the last question. Do we have the last one here, I think? Let's see. Let me go downstairs fast. So we see we're finishing this. The last question. We can go back to number 1. See? Let me get a little discussion. As in a little talk. To pass CSEC maths, this is what you have to do. The questions, there'll be 11 questions on the paper. I think it's 11 questions. You do the first 8 questions, just compulsory. And you do the last 3. I think it's 11 questions on paper, if I remember. To pass CSEC maths, this is what you have to do. You have to divide the number of time you have by what? By the number of questions. You have to do the exam smart. You cannot. Let me tell you this, guys, as a little trick. There's tricks in trade. you can get a grade 2 or a grade 1 by not completing the paper, because CSEC mark for concept, okay? So don't say because you don't finish in a pass, or you not get a good grade. So try to use the time that you have. You have to do the exam smart, because time keep moving. Time move like a bullet, you know. You have to work with time. Divide the total number of hours you have by the total number of questions, and you spend each of those the time that you actually get. When if you say divide by say 11, whatever the number of questions there are, by 2 hours and whatever minute, to call it 81 2 is it 2 hours and 40 minutes still? Is it 2 hours and 40 minutes? I think if it still remains the same, 120, 160, whatever it is, okay. So what you have to do, divide it by the number of questions and then spend that number of time on each question. And once you finish, the time is up, you move on to the next question. Because each question deserves a fair chance. Don't say, boy, time up, I never get to the question. Because you have to try to make sure you do as much question as possible. All right, let's move on now to the last question now. And we can go back to the first question again, in case you didn't understand that first question. Now, we have this called a distance time graph, or a velocity time graph, okay? So come again, we have distance time graph and velocity time graph. Okay, let's start this one now. So this one now, guys. Okay, all right. I think I have time to tell this one quick, guys. Let me tell this one quick now. I think I have time. Now for distance time graph, this is not distance time graph. What if I don't want to go? For distance time, come guys, are you with me? For distance time graph, what you have, let me show what is true. Never you forget this now. This is not a distance time graph, it's a velocity time graph. For distance time graph, this is what is true. Never you forget this. This is not a distance time graph, it's a speed or a velocity time graph. Velocity time graph or speed time graph, okay? But for distance time graph, this is what you need to know. Distance time graph. This line here represents what? Constant what? Constant, who can tell me? Constant.
Please, can I'm not sure. I'm new to that word.
Constant velocity, right? Is it mean constant velocity? Yeah?
So what's that?
No, hold on there. No, no, I'm saying if you have a distance time graph, where you have no distance against time, this will be like distance, this is distance. So we call this here distance against time. Distance against time. This is not your question though. This is a speed time graph. Speed is same as velocity. But for distance time graph, this line would represent what? Constant what? Constant what? Velocity?
Velocity.
Yeah. This will be what? What? Body at rest. Body at rest. You guys know the body will be at rest. The body stop move. Body at rest. You need to know for your exam. And this one is also constant velocity. Follow me? But you're going in the opposite direction. So you have constant speed or constant velocity, body at rest. So the horizontal line in a distance time graph represents body at rest. And this is now what? Constant again, velocity, but in opposite direction. No, but our question is not that. Our question is what? Speed or velocity time graph. Okay. Now, if that was a time graph, guys, for a speed time graph now, can you tell me what is true? Let me tell you what is true now. It's for a speed time graph. For a speed time graph, this represents what? What does it represent?
Constant velocity.
Excellent. Excellent. No, velocity or acceleration. No, man, not velocity. Constant acceleration. Because the gradient is positive. Acceleration, not true?
Yes,
Come
sir.
again. This is what? So in a speed time graph, this line represents constant acceleration. This one represents what? Constant velocity. This is now constant velocity. Yes, constant velocity. Don't forget that now. Come Genesis now. Walk with me. The student who listens the most learns the most. Constant acceleration, body at rest is a horizontal line. The body's at rest. No, sorry, I said the wrong thing. Come again. Constant acceleration, constant, the horizontal line is what? Constant velocity. And this is what? Constant deceleration. Ah, see here, my friend. See here. Ah, this is what? Constant deceleration. Ah. Constant means uniform. It doesn't change. Uniform. The word is uniform or constant. They use it interchangeably. Constant deceleration. So in a distance time graph, as opposed to a speed time graph, you need to know the difference between what? Between the different things, okay? Take a picture for me quick. Oh, we can make up handwriting. This marker is not doing me justice at all, guys. Not doing me justice at all, this marker. Cool. All right, let's move on now. Having said that now, guys, that's what the man asks now. The man says that now, calculate. Oh, let's read the question from the beginning first before I talk about what they ask us to do. Oh, it only has 2 parts. Good. Not bad. The question says that. Okay, cool. The question says, okay, Monty is cycling at 12 meters per second. You need to know what that 12 meters represent. What does a meter per second represent? You need to know what it represents. After 4.5 seconds, it starts to decelerate. And after a further 2.5 seconds, it stops. I show the speed time graph is shown below. Okay, cool. So Monty is cycling at 12 meters per second. What does the 12 meters per second represent?
12 meters per
second. Yeah, what does it represent? Constant. Constant what?
Acceleration.
Acceleration.
No, man. No. That's not true. No, guys. This is a speed time graph. The horizontal line represents what? Constant
Deceleration.
Velocity, yes. Velocity, yeah. Or constant speed. And the mere fact that he had meters per second, it has to be what? Speed. Yeah. Not true? Talk to me. Right. Cool now. So that's constant velocity or constant speed. Cool. After 4.5 seconds, it starts to decelerate. Can I show the line, my friend? Come, Junior says no. The student who listens the most, learns the most. This is the line that the man is talking about right now. See it here? See there? After 4.5 seconds, which is from here to here. See there? From here to here, we start decelerating. This graph represents what? Constant. Deceleration. Excellent. Well said. Okay, now listen carefully now. You're asked first to find the constant deceleration. What do you find constant deceleration? It is what? It is the change in your speed divided by the
time.
The time taken to what? Time taken to make the change, right? So come again, so guys, write down for me enough, guys. So the formula for constant deceleration is the change in your velocity or the change in your speed divided by, because it's really what is an average, like even an average, divided by the time taken to the entire time taken to what to for that to happen. All right. So what we really have, ladies and gentlemen, is what is the total.
Can you see, please?
Yes. All right. The change in your speed, yes, divided by the time taken. The time taken, as in how long it take. So you're talking about difference and the difference between something. So the change in your speed will be from what to what now? What will be changing your speed? 12 take away what? Can I ask a question, by the way? Which part of the graph do you want to find? Which part of the graph? You're asking
the
about?
part where he decreased.
Can I show you? So it's really the gradient. Is it the gradient then? That the gradient? Is that the gradient we're finding really? Let me show you the gradient of the line. Let me see if I can show what I'm saying. So we are focusing on only this part, ladies and gentlemen, this part only. I think I need to use a
Sir, the
green.
part that is slant, we're not focusing on there,
This
sir.
part only. See it here?
Yes, that part alone we're focusing on.
Which is this part here. Everybody with me? So we want to let me draw it properly upstairs here for you. And that's the triangle, like a rectangle triangle. So we are trying to find the distance from here to here. This distance. That's it, what the time divided by this distance from here to here. Okay? So the deceleration would be what? The change in your what? Your speed divided by the time taken. So what would be your change in your speed? It went from what? From what? From 0 to 12. Agree?
Yes, sir.
So it's 12. So from here to here is 0 to 12. No, wait, am I saying the right thing here? The from here to here is 0 to 12, from here to here. Not true?
Yeah.
So what I want to find really is this line here from here to here. So the change is what? From here to here would be what? What would be this distance here? 0 to 12. No, I indicate the wrong line. The wrong line I indicate. This line here, man. Sorry, man. The wrong line. You guys now tell me I do the wrong thing, man. Guys, you have to be confident. You have to be confident. From here to here, man. See there? I just match highlight here, so. Yeah. The change. It's time the grade is the line, grade to the line. From here to here is 12, not true? Okay, it goes from 0 to 12, not true? See there? So it is
Yes,
12.
sir.
And from here to here is what? It goes from what?
4.5.
To what? To 7. So it is 12, take away 0, which is 12, this number here, which is 12, take away 0. That's how long this line is. And it is what? 7, take away what? This is about 4.5 right here, so 4.5. So the answer is 12 divided by what? 2.5, whatever that comes to. Yeah, because 4.5 from 7 is 2.5. 2.5 is about what? This is 5, this is what? This 2.5, 5 over 2, so it's 12 divided by 5 over 2. So it's 12 divided by, so it's 24 divided by, is it 24 divided by 5? Yeah, 24 divided by 5 though. 24 divided by 5, which is about what?
So where I get 24 from?
Eh? Oh, me not
So
do the
where I
wrong
get
thing,
the
man.
24 from?
Me just use fraction. Yeah, man, because I say it's 12, because 2.5, 5 over 2. That's 2.5, 5 over 2. So you don't have to do it my way. This is the calculator. I think you can get 4.8 or something. 4.8. Because 5
Yes,
4
sir.
is 20. Yeah, you get 4.8 because 24 divided by 4. I can't convert to a fraction. You can use the calculator directly. And because its deceleration is what? Meters per second square. If you leave it off, then leave off a grid. If you leave it off, you leave off a grid. It's meters per second square. Everybody with me?
Yes.
Okay, very good. All right. Any question about that one? And the last part now, the question now, and we bring this to conclusion now, the last, because this is this one going to be Thursday. We're going to do this part on Thursday. Oh, okay. So the last part of this now says, calculate the Monty's average speed over this 7 seconds. Okay, for the entire seconds. Now, let me teach you something. You never you forget this, guys. Never you forget now. The average speed of a distance, let me say the right thing. The average speed of a speed time, well, let me use velocity instead of speed again. The average speed of a velocity time graph is given as the total distance divided by total time taken. Come again, write that for me. The average speed is what? Total distance over total time. The deceleration was at the gradient of the line. Don't forget that. So the first part was the deceleration was at the gradient of the line, that gradient of that line, which is vertical rise over horizontal run. So the gradient is what? Difference in the y's divided by difference in the x's. That's how we subtract difference in the what? The x divide difference in the y's, if I call it difference. So the gradient is like the difference in the vertical divided by difference in the horizontal. And that was the deceleration, was the gradient of that line. So the gradient of the line is now the deceleration or the acceleration, the gradient of the line. But for now, this average speed now is really the total distance divided by total time taken, okay? But we know the total time taken already. What was the total time taken for the journey in seconds? Seconds. What was the total time taken?
7.
Excellent. Well said. Very good. Excellent. 7. It was 7 seconds. Very good. Now, what is now the total distance? No, nobody forget this, guys. Nobody forget this now, guys. No, write down this. If you're going to forget it, write it down now. To find the total distance when you have a speed time graph or a velocity time graph, the total distance is the area under the graph. Yeah. Come again. The total distance of a speed time graph, same as a velocity time graph, the total distance of a speed or a velocity time graph, yes, represent the area under the graph. The area under the graph will give us the total distance. Everybody get that?
Yes.
Let me write down the formula now, as I just mentioned earlier, that the average speed, my friend, let's call it AS for time, because I'm not have time to write everything. Average speed AS, write the word properly in the book. Average speed equal to total distance divided by total time taken. Total time. Write me properly in the book, guys. Don't write the shorthand. Write it so you can remember, because you might forget what it means. Don't follow me now, guys. Write the correct thing in the book. Average speed is total distance divided by total time. But the total time going to be 12. We know that is 12 below. We want this top number now. We want the total distance. But for the total distance, you need to find the area under the graph. Because the area under the graph give us the total distance. No, but the area under the graph is the area of a trapezium. Because that graph is a trapezium. Everybody see it? Yeah, man, it's a trapezium, guys. Eh? Hello?
How is that?
Guys, you must not only look, you must see. You must not only look, you must see. This is your trapezium. See your trapezium here? This is your trapezium. Yeah, it's a trapezium, my friend. See the trapezium here, my friend? That's it. That's a trapezium. Yeah. See it here, sir?
Oh, because of the diagonal line.
That's a trapezium. This could be a trapezium take two forms. It take that form or it take this form. So that's a trapezium. So we're going to find the area of the trapezium and then school is over. What's the area of a trapezium? The area of a trapezium is what? The sum of the parallel side divided by 2 multiplied by the perpendicular distance. With the height. Exactly. You're right. Yeah, man, you're right. Let's go now, guys. Come join us now. Let's bring to this conclusion now. So let's find the total now, distance now. Help me now. So the distance will be equal to, so distance, total distance, which is total, of course, distance, will be equal to 1/2 the sum of the parallel side, because of trapezium. So the parallel side goes from what to what now? From here to here is what? 4.5, agree? So it's 4.5.
Yes, sir.
Yes. Come join us, walk with me. Plus, from here to here is what? 7.
7.
Times, excellent, times. This distance is
12.
what? School. And the
sir.
answer come to 69. I know say enough time. I'm write it very fast. It come to 69, okay? So we know school is now over. Oh, this 9 needs some cornmeal porridge. I'm write this down properly in some cornmeal porridge. I'm write it properly, the 9. So it's divided by, so 69 is our total distance. Now school is over. Wicked. Look. So the average speed now, what they ask us to find now, the average speed, AVERAGE speed, will be equal to 69 divided by, what we say, what the time was what again? Divided by what? By what? What was it again? What was the time again? Divided by what? By 7? 7. If I wrote 12, if I wrote 12 is a mistake, it has to be 7, not 12, because the time was 7. See there? 7 seconds. See there? So if I wrote 12, it would have been a mistake. It has to be
Yes,
7.
sir.
Yeah, and the answer would I think gonna be about 9.8, 9.86. 9.8. And because they asked about average speed, it has to be what? Meters per second. The meters per second. And that's it, school is over. That's it, school is over for that question.
So,
So
sir,
that's
9.8.
meters per second. Is that
Yes, sir,
approximate?
9.8.
Yeah, meter per second. That's the average speed. All right. So we can move on now. Take a picture for me quick and we move on. Go back to the
Sure, quick question. Sir, if you didn't want to use the trapezium formula to find the total distance, could you just like find the distance of the
Well, if you can do
triangle
it,
ears
if you
and
can do it a different way, if you can go
then add it
around.
together?
Okay, you want to find the area? Yeah, man, you can find the area of the square, find the area of the trapeze, the triangle. You can find the area of here, the area of the square
And the
first,
triangle
and
and
add
then
it
add it
together.
together.
You're a genius. You're a genius.
Yes, sir.
Give her a thumbs up, guy. Give her a thumbs up.
Sir, could that?
No, you're right, man. You're right. Let's make sure you don't make the mistake. No matter which way you do it. Look here, guys. Maths is a true science, my friend. Maths is stronger than Obia. No matter which way you do it, you get the same answer. Yeah. Excellent. I love that. Find the area of the square, find the area of the triangle, and add them and get the total area. And you get the same answer. Okay. Guys, I know time is almost up. We have 2 minutes leave. Mrs. Johnson is online or Mrs. Johnson online. Can I just go on to this first part again that we actually never understand?
I am still here, Dr. Morgan, and yes, you can revisit. You can revisit the question. We still have a little time.
We still have yes. Thank you very much. God, I think everybody seemed to be okay so far with the other questions except for the number one. I call it my number one as in this. Yes, this one. Okay, cool. Guys, let's see now. What I was trying to say to you in CSEC now, if this question come, it's called linear programming. After you form your inequalities, you're going to sketch a graph of the equation first. And you're going to use the inequality to guide you to know which part to shade. Everybody understand what we shade? Why we shade what we shaded?
No, sir.
All right, cool. Let's go quick again now. All right. Do I need to go back over the 4 inequalities, how they were formed? Or you guys remember how they were formed? Do I need to go back over
I was late, so I don't remember.
Oh, all right, quick. All right,
Sir, can you go over it, please?
All right,
so you can go over it, please, because my phone was breaking up, so I wasn't hearing you clearly.
All right, so it's a rental car has X cars and Y minivans, okay? So it has X cars, so we call the number of cars X and the number of minivans Y. The company has at least 8 vehicles altogether. So because we have what? X cars and Y minivans, and they have 8 of them altogether, we can form our first inequality. Because it says it have at least 8, but at least mean what? That or more. So at least means what? It can be 8 or greater than 8, okay? So the first inequality is X plus Y. Let's find it is going to be X plus Y. X plus Y is greater than or equal to 8. Everybody saw get that first inequality? Those who came late?
Yes, sir.
Because at least means that or more. At least 5 means 5 or more. At least 8 means 8 or more. Okay, the next one says the number of minivans is less than or equal to. That one is straightforward. The number of minivans is less than or equal to cars. That's what it says. So the number of minivans is Y is less than or equal to, I put a plus sign, equal to what? X. That's our second inequality. Because the number of minivans, but we call the number of minivans Y and number of cars what? X. It's a number of minivans is less than or equal to what? The number of cars. So Y is less than or equal to X. And the last inequality now says now, the number of cars is no more than what? 9. What is no more than that? What does no more than means? No more than 9 means what? 9 or less. Okay, cool. So that means the X is car. So X is what? Less than or equal to 9. And that was how we formed the 3 inequalities, okay? And then now we're supposed
It's
to
not
know.
simple. Just write the greater than or less than sign and equal
Yeah,
sign.
exactly. That's what it is. Yeah, exactly.
Okay.
And the last part now, we don't have time to do it. Let us bring this to this conclusion. Let's do this the last one. Call it a day. Call it a night or evening. It says that a car can carry 4 people and a minivan can carry 6 people. There are at most mean that are what? Are less. At most 60 people to be taken on a tour. So because X represents what? Cars. Y is what? Minivan. What will be our inequality? It will be 4 times what? X plus 6 times. I might have said cars is whatever. Yeah, car is X, right? 4 times X, because 4 people can hold in a car, so 4 times X. 6 in a van, minivan, so 6 times Y equal to? No, not equal to. It must be at most mean that or more. No, I said the wrong thing again. I said it again one more time by mistake. At most mean that or less. At most 60 means 60 or what? Or less. At most. It cannot be beyond 60. So what's our inequality, guys? It is 4x, walk with me, plus 6y less than or equal to 60. But to get this proof now, so show that 2x plus 3y less than or equal to 30, you're going to divide through by 2 now, and you get that answer, you're done. Okay? Divide through by 2, and then school is over. And that's it. Okay? All right, ladies and gentlemen, that comes to the end of this session. So I'm going to invite Mrs. Johnson to give her a closing remark, and yes, and send you guys to bed.
So thanks to Dr. Morgan for taking us through the session today. Be reminded, we looked at algebra, relations, functions, graphs. So we started with part 1. And on Thursday, that is the day after tomorrow, which can somebody share with me the date? What's the date? The day after tomorrow, that's April what?
30th.
30th. So on Thursday, April 30th, Dr. Morgan will be back here with us, and he will take us through part 2 of what we started today. We're going to be working some different CSEC questions, but students, thank you so much for staying with us throughout the day, throughout the evening, as a matter of fact. If you did not get a chance to post the name of your school in the chat, please do so that I can give you a shout out on Thursday, and I can shout out to your school on Thursday. So thank you so much for being with us this evening, and we will see you on Thursday, April 30th, same time, 5:30 p.m., same place, right here on Zoom. Please be reminded too, if you want to see a recording of this evening's session, you can just log on to YouTube and just search for Region 7 Mathematics Team, and you will see us there. All the sessions that we would have been facilitating from last week, Tuesday, they are on YouTube. So you can head to YouTube and you will see us. Thanks so much to Dr. Morgan once more for taking us through this evening, and we look forward to seeing you on Thursday, students. Take care. Bye-bye.
Thank you very much, everybody. Thanks, Mrs. Johnson, Burrell.